Independent and dependent variables. Example 1. The cost of renting a car is a function of the miles it is driven. They give us an equation, C equals 35 plus 0.12 m. They're asking for the independent variable and the dependent variable. If we look back at the equation, we see that we have two variables. I have C and I have m. C represents cost and m represents miles. In algebra, when we see a function of, like this, it means that something is depending on something else. So what I do is, if I see is a function of, I mark that out, and I write depends on in its place. Okay, so the dependent variable is going to be the cost, because it says the cost depends on. So dependent variable. So here I'm going to write cost, and the variable that we're using is C. For the independent variable, it's miles, and we're using m as that variable. Example 2, the surface area A of a cube depends on the length of the edge S. The equation is A equals 6s squared. We have two variables here. We have an A and an S. A represents the surface area. S represents the length of the edge. We're looking for a dependent variable and an independent variable. In this one, the problem pretty much spells it out. It says the surface area A of a cube depends on the length. So the dependent variable is the surface area, because the surface area depends on the length. So we're going to write, I'm going to put surface area, and we're going to use A for that variable. And then the independent variable is the length of the edge. So length of edge, and we will use S to represent that. Example 3, a custom illustrated sign can be made of a cost of $25 for the materials and $10.50 per square foot X for the artwork. The equation that represents the situation is C equals 1050X plus 25. First, I see that we have two variables. We have C and X. So when I go up to the back up to the word problem, it says the cost of the materials and 1050 per square foot X. So square foot, the number of square feet is represented by X, and for each square foot that I have, it's going to go up $10.50. And since they've already given me the equation, I know that this is the thing that's changing each time. So this C, or the cost, is going to depend on how many square feet of board that I buy. So the dependent variable is going to be the cost, because the cost depends on it. So we will write cost, and we're using C as that variable. And the independent variable is going to be square feet. And we're going to use X as that variable. Now, it says cost is a function of what? Or cost depends on what? The number of square feet. The number of square feet. Okay, example 4. C equals 2 pi r. Here it tells us that C represents circumference and r represents radius. I see that I have a single variable here and it equals this. So this is what's changing each time. It's 2 times pi times r. So the circumference of a circle depends on what the radius of the circle is. So circumference of a circle depends on the radius. So we're going to write the radius. If the circumference depends on the radius, that means it's the dependent variable. So circumference. And we use C to represent that. And the independent variable is going to be radius. And we use R to represent that. Example 5, they give us a table here, and in the table we always have our x values on the left, y values on the right. I see for my x values we have number of aluminum cans, and they give us the different amounts of cans. And in y, they're telling us it's the amount of the refund, and they show us how much they're getting refunded. Okay, in algebra, one thing we like to write and say is that y depends on x. So whatever we have in y is always going to depend on what's happening here in x. So if I have 5 aluminum cans, I'm going to get 75 cents. I won't get any money if I don't have any cans. So the amount of money that I get here depends on how many cans that I turn in for recycling. So our independent variable is going to be the aluminum cans. So I'll put x is going to be independent. And our y is the amount of refund. The amount of the refund is going to be our dependent variable. Okay, example 6. We have a table again. This time we're going to label our x and y. And we look at the labels we have here. It says the number of hours worked is our x, and pay is going to be our y. Our phrase, we have y depends on x, so that means this is always going to be our dependent variable. So I'm going to write dependent, and it means the other one is independent. Okay. If we think about this, we have hours worked and pay. So what that's telling us is that the amount of money that we earn, or how much we get for a paycheck, depends on how many hours we work. If I don't work any hours, I'm not going to make any money. If I work 1 hour, I'm going to make $9. The amount of money that I make here depends on how many hours that I've worked. Okay, example 7. Once again, we look at y depends on x. We will label our x and y in the table. X, y. Y is going to depend on x. So our dependent variable is going to be the amount charged. So dependent. And x, the hours worked, will be the independent variable. What that's saying is, if I have someone come to my house to work on, say, my air conditioner, they're going to charge me a certain amount of money, but the amount of money that they charge me depends on how many hours they do the work at my house. Example 8, we have side length and area of a square. We will label the x and y. So side length will be x, area of a square will be y. And we see that y depends on x, so the area of the square is going to depend on the side length. So the area of the square is the dependent variable, and the side length will be the independent variable. Okay, so different size squares are going to have different areas. So the area is going to depend on how long each of the sides are. Okay, it says identify the independent and dependent variables for each situation described below. In this first one, it says John measures the length and width of each side of a rectangle. He uses those values to calculate the area. I'm I don't really like this example very much, but we will say that we'll go ahead and identify the dependent variable. So we need to be able to calculate the area of a rectangle. So our dependent variable is going to be area, and we would use A to represent area. Now for the independent variable, this is why I don't like this problem. We have two different variables, length and width. So on this one, I'm just going to go ahead and say this wasn't a very good problem. I'm just going to mark it out here, and we're just going to identify the dependent variable on this one. On the second example, y equals 4x plus 1. So we see that the value of y depends on what's happening to this x. So we're multiplying 4 times x, and then we're adding 1 to it. So this is where my changes are happening, and whatever happens here gives us the value for y. So the value of y depends on this x. So y is our dependent variable, and x will be our independent variable. Okay. David measures how many inches his tomato plant grows every week. In this problem, we see David's measuring the number of inches that his plant grows every week. So we have to still identify independent and dependent, and the number of inches that the plant's going to grow depends on how many weeks that the plant's been alive. If it's been alive 1 week, it's going to grow a certain amount of inches. If it's been alive for 2 weeks, it's going to grow some more inches. So our dependent variable is going to be inches, and that's our dependent. And our independent variable is the number of weeks. So weeks. Okay, Mark works full-time as a busboy at a local cafe. He earns $6 per hour and then an additional $3 per hour for each hour over 40 hours that he works per week. So we have two different things we're talking about in this problem. We're talking about hours that he works and the amount of money that he earns. Once again, if I don't work any hours, I'm not going to make any money. So the amount of money that I make depends on how many hours I work. So our dependent variable is going to be the money earned. And our independent variable is the number of hours that I work, or that Mark works. Okay, the number of gumballs G that can be packaged in a box with a volume of V cubic units is given by this equation. G equals 40V plus 15. We see that G is our number of gumballs that's going to be packed. So we have 40 times V, which is the volume of cubic units, plus 15. So the number of gumballs depends on the volume of the box. So for our dependent variable, we're going to write G, or number of gumballs. So we'll write gumballs, and we're using the letter G to represent gumballs for our dependent variable. Our independent variable is the volume of the box, and we'll use V to represent the volume. So the number of gumballs depends on the volume of the box, or the size of the box that we're putting them in. It says Jake works as a sales representative. He earns $1,275 per month plus an 8% commission on his total sales. Here I see he earns $1,275 per month plus a commission of his sales. So we're going to identify independent variable and dependent variables. Okay. So we're talking about earnings and sales. Those are two different variables. His earnings are going to depend on how many sales that he has. So if he doesn't make any extra sales, he's not going to earn any additional money from the commissions. So we will say that the dependent variable is the earnings. And if I was going to give that a variable, I might put E. And our independent variable is going to be the sales. And we could use S to represent sales. So the amount of earnings depends on the amount of sales that he has.